Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. Here's a problem for today for exam LTAM. For a special 10-year deferred whole life annuity due of $50,000 on a 62-year-old, you are given that level annual net premiums are payable for 10 years. A death benefit payable at the end of the year of death is provided only after the deferral period and is the sum of the net premiums paid without interest. A.62 is 12.2758. A.62 angle colon angle 10 is 7.4574. The cost of life insurance, a term life insurance over 10 years on a 62-year-old, this is a single net premium or single benefit premium, it's 0.0910. And the sum from k equal 1 to 10 of term insurance over k years on a 62-year-old is 0.4891. Calculate the net premium for this special annuity. And here's the solution. So let us write P for the level annual net or benefit premium sought. Using the equivalence principle, we write the actuarial present value of premiums equal to the actuarial present value of benefits. So PA double dot 62 colon angle 10. That's the present value, actuarial present value of the premiums. It's equal to 50,000, which is deferred by 10 years, life annuity due. So you can write it as A double dot 62 minus A double dot 62 colon angle 10. You're just removing the first 10 years and then it's paid for life after that. Plus PIA 62 colon angle 10 1, because the refund of premiums is effectively an increasing life insurance, because the first year it's one premium, second year it's two premiums, and so on over 10 years. And then we solve this for P, and P is equal to 50,000 A double dot 62 minus A double dot 62 colon angle 10. Divided by A double dot 62 colon angle 10 minus IA 62 colon angle 10 with a 1 above the 62. And the bottom part can be written as A 62 colon angle 1 over 62 plus deferred by 1 year insurance, 1 year term insurance of 2 plus deferred by 3 years and so on. And the last one is deferred by 9 years insurance of 10 in the last year, so in the 10th year. We do not know the second term in the denominator. That's the problem here. But consider the expression, the sum from k equal 1 to 10 of A 62 colon angle K1, whose value is given in the problem. So we have that this expression that is given is equal to A 62 colon angle 1 with a 1 above the 62, then put 2, 3, and so on up to 10. And if you separate the insurance in the first year, the insurance in the second year, and so on from all these terms separately, then it's 10A 62 angle colon angle 1 with a 1 above 62. So cost of term insurance of 10 in the first year, then deferred by 1 year, term insurance of 9 in the second year, and so on up to 1 in the final year, deferred by 9 years. If we take the sum of the second term in the denominator that we have and the expression we just derived, one of them goes up, the other one goes down. You know, I call this the 7-year-old Gauss rule, if you have two expressions, one of them goes up, the other one goes down, and they do it in the same fashion and at the same rate, then if you add them up, you get something that is constant. So we obtain an expression that just has a coverage of 11 for death in any of the next 10 years, but split into separate years. First year, then deferred the second year, then deferred, and so on. And that's the same, of course, as 11 times 10-year term on 62-year-old. So that's got to be equal to 11 times 0.0910, which is given in the problem. Then based on this, the expression that we're looking for, whether it was in the denominator for the expression for the premium, is equal to 11 times that 10-year term minus the sum, which is equal to the sum from k equal 1 to 10 of k-year term coverage, which is the expression given in the problem. So this is 11 times 0.0910 minus 0.4891, and that difference is equal to 0.119. So that thing goes into the denominator as this expression subtracted from the annuity. And at this point, we actually have everything that we need in the expression for the premium. We plug it in and calculate it, and it comes out to be 34,687.2075 approximately, and that's answer D. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.